Hello, today I'm going to show you how to make a room temperature lava lamp. Now for those of you that don't know what a lava lamp is, they were very popular in the 1960s and 1970s. They had a little heating element underneath them, and there were two types of substances in there that were not compatible on a molecular basis. That means that the molecules didn't like each other very much. And when the heating part of the lamp was operational, you viewed these big bubbles rising to the top, and as they cooled down, they'd come back to the bottom. And we're going to do one of those at room temperature with things that you can make from your home here. And there's actually a lot of neat chemistry things going on here. Now, none of the chemicals that you're going to be using today are dangerous to your eyes or anything, so it's not necessary for you to wear eye protection, but of course you can always do that. Since I'm in a chemistry lab here today making this video, I'm going to wear some eye protection over my eyes just because I'm working in a laboratory. Now, what we're going to do is we're going to show you how AlkaSeltzer tablets interact with both water and vegetable oil. So right over here, I have a beaker with some water in it, and I have a little cup here with some vegetable oil. Now, AlkaSeltzer that you can buy at a drugstore, AlkaSeltzer has three main chemicals in it. One of them is aspirin, and that does the pain relief, and then one is sodium bicarbonate, and the other one is citric acid. Now, all except for the aspirin, the citric acid and the sodium bicarbonate are very soluble in water. They love to dissolve in water. That's because of the shape of the water molecules relative to the shape of the thing it's trying to dissolve, which is the sodium bicarbonate and the citric acid in the AlkaSeltzer. So we have an adage in chemistry that like dissolves like. Molecules that have similar structures will dissolve in each other. So what I'm going to do is put the AlkaSeltzer tablet in the water right here, and you can see right away bubbles forming. That's because the solubility of the citric acid and the sodium bicarbonate, they dissolve really well, and in the chemical reaction with water, they form carbon dioxide, which is the bubbles that you see. Now I'm going to do the same thing with the vegetable oil. The vegetable oil molecules are really, really long molecules, and they are not very compatible with water. That is, if you pour the oil, which we're going to in a few seconds here, pour the oil with the water, it'll form a layer on top. It's not as dense as the water, and it will not dissolve very much in the water. It might dissolve a little bit. When I put the AlkaSeltzer tablet in here, it goes to the bottom there. We see a few bubbles when you first put it in there from some cracks and crevices in the the tablet, but for all practical purposes, it does not dissolve in the vegetable oil. We're going to make use of that in our experiment. Now we're going to use this that we've seen what the AlkaSeltzer tablet does with the vegetable oil in the water. We're going to make our little lava lamp. And I want you to think about what's going to happen when we do this. Now the first thing that we have here is we have some water. And to make things a little bit more visible to you, we're going to put a drop of food dye in here. Now you don't really need any more than that. You don't want the liquid to be too dark, like so. And we'll kind of swirl it around a little bit. Or we can stir it like this. Now, even with a drop of food dye in there, it's a little dark for me, so I'm going to just pour some of it out and put a little bit more water in here. It's a little bit lighter color here. Now, since the molecule structure of the water and oil are not very much alike, water is kind of a bent with a hydrogen on both ends of an oxygen, but the molecule's bent kind of in a V shape. The vegetable oil molecule is very, very straight and long molecule. I'm going to pour some in. Since they don't like each other, we would expect two layers to form. And since the vegetable oil, we're going to see is less dense, forms a layer on the top. Now what I'm doing is I'm carefully pouring it down the side of the beaker, and you can see the layers start to form. If you pour it down the side of the beaker, it won't form as many bubbles in there and you want it in here so there aren't bubbles of oil in there. So now we can clearly see the two layers that we have. We might see a little bubble in there, but not very much at all. Now, based on our first experiment, what I want you to think about is what's going to happen when we add the AlkaSeltzer tablet. The AlkaSeltzer tablet sinks to the bottom, and it loves to react with the water, and now it's forming bubbles of carbon dioxide. But look what the bubbles do. The bubbles will start to surround some of the water as it's coming up through here, and it makes some spheres of the dyed water. All right? But they stay as spheres in there because they don't like the vegetable oil, but then the bubbles will surround the water, making it less dense than it would be at the bottom, but then when it starts to rise to the top and some of the bubbles break, the density goes up again, and it decreases the density of that bubble with the water in it, and then it goes back to the bottom. So we have this constantly changing little spheres of dyed water forming with bubbles around them, gets to the top, the bubbles break, and then they come back down. And we can just keep it going if we add another AlkaSeltzer tablet here. Will eventually happen. There's a lot of neat things going on here. The AlkaSeltzer tablet will get enough water and bubbles around it where what's ever left of it will eventually make its way to the top, and you'll kind of see it fizzing around on the top a little bit. But it's fizzing around in the water really, and not the vegetable oil. So I think this is a really cool lava lamp to make at home. And you can try different ways of doing this, try different dye colors, different amounts of water versus different amounts of oil, and a really fun experiment to show you the differences in how things dissolve in water versus vegetable oil.